I'm David Gibson from Red Hat. The title is Rethinking Machine Types, but actually I'm talking more generally about how you configure what virtual hardware you want in your machine. It's a cluster of related problems in that area and some no total solutions, but some approaches which might help. So, what's the problem? I'm going to assume everyone's more or less familiar with the qemu model. You say no defaults to start with to get rid of legacy stuff. Then for every device in your system, you put -device and various options, and each one of those becomes a device in your virtual machine. Very straightforward, very simple, very easy to understand. Except, of course, that won't work, because you can't do any of this until you choose a machine type, and when you choose a machine type, you get a whole bunch of other devices that are standard for that device. I've used P-Series here as an example because that's the one I know best, but the same is true for PC, for everything. They'll add one sort of device or another, as well as various firmware interfaces and so forth. So you can't really get away without machine type because it performs system-wide setup across your virtual machine. That needs to be done. But the problem is it also adds a bunch of extra devices, even when you say no defaults. Exactly what extra devices it adds can depend on other options, even options that aren't obviously related. And so essentially, it's not easy to discover what the behaviour of the machine type is going to be in terms of what devices it will create, which is awkward for management layers and so forth. So, going on, how do we talk about what hardware is in a VM across the entire stack? So I'm using Overt here as an example, but you'll get a similar picture with OpenStack or other things. We start with entries in the Overt database which describe the virtual machine and say what hardware it should have. It turns them into XML RPC parameters that go to VDSM. VDSM turns it into libvirt domain XML. XML turns it into a qemu command line. QEMU turns it into its internal QOM model, and QEMU will then convert that into something to tell the guest. And the two common forms, there are lots of forms for the many different machine types, but the two that are common are ACPI, used on x86 and some ARM, and device tree, used on Power and some ARM and some other things. And so problem number two, or at least ugly thing number two, is do we really need, 6 different methods of describing the virtual hardware as we move through the stack, all of which are really quite different. So why are there so many formats? What's different about the different descriptions of the hardware moving through the stack here? The biggest difference is how exactly they describe the hardware. So what I'm calling a distinction between a loose description of the hardware and a precise description of the hardware. So a loose description, you're just saying you want this much disk. I don't care how you get it, you want this much disk. And at the precise end, you say everything there is about the disk, what model it is, its unique IDs, if it has those, what controller it's attached to, how the controller is attached, any bridges there are between the controller and the device, and all this for every device on the system. So the various different models we have sort of lie at various places along here. The modes that Overt and OpenStack and virtinstall use are all fairly loose. Obviously, the guest and QEMU both need to have an exact image of the hardware. QEMU because it is the hardware, and the guest because it needs to drive that hardware. And so ACPI and device tree and QDev are all as precise as you can get, essentially. qemu command line's almost there. You add a few defaults. libvirt XML is the weird case because it can actually vary depending where it is. When you create a new VM with libvirt XML, you'll probably be fairly loose in the description, just say roughly what you want. But libvirt, that's the only description of the hardware that libvirt maintains, which means by the time it actually runs qemu, it modifies that XML internally into something that is quite precise. And as I'll be discussing as we go further, how precise it is, the fact that it's sort of not 100% precise can cause some complications. And we do need sort of both ends of this spectrum. When you're creating a VM, you don't want to have to describe whether you're an actual person or whether you're a management layer. You don't want to have to describe absolutely every detail of every device on the system in order to create your VM. So you need the loose description, only sometimes you do want to control things precisely because you want to test something specific or you have some reason that you want a particular type of virtual hardware. Now, obviously, as I said, qemu and the guest need a precise description. And so through the stack at various stages as you move down the stack, the loose description is converted to a precise description by selecting default implementations for things, by adding standard or default devices, and by assigning addresses. There's other things that can happen, but they're the three main techniques that are used to make a description precise. Excuse me. So, what happens when we add migration into the picture? For migration, the destination has to have identical hardware to the source as far as the guest can tell. But how those devices are implemented might vary. The simplest example of that is if you've got a virtual disk image that's on a different path on the host on your destination from the source. No reason you can't migrate that. You just need to rearrange your pointers, and that should be fine. There's other differences you can. There can be reasons you want to change the back end in ways that should be invisible to the guest, and that shouldn't stop you migrating. So libvirt manages migration at the moment, although most of the implementation is in qemu. And that means libvirt needs to know the precise hardware description so that it can start qemu on the destination host with exactly the same guest hardware as it had on the source. And what that means is that although qemu has a bunch of perfectly good code for assigning addresses to devices when you ask for them, libvirt duplicates all that because it needs to know where all the devices are so it can create exactly the same ones on the far end. And so we have code duplication, which is, generally a bad sign. So Hotplug is another complication. Obviously, when you hotplug devices into qemu, it has to keep track of what they are. It has to know what the hardware is. But the complication comes when you combine that with migration. The destination still needs to have all the same hardware devices, and that includes all the devices you hotplugged on the source between when you started the VM and when you started the migration. And that means, again, in a similar way, that libvirt needs to track all the hotplug devices and update its view of the hardware so that it will be in sync with what's hotplugged. And again, this is more duplicated effort. qemu and libvirt are essentially tracking the state of the guest hardware in parallel. Sorry, I shouldn't say the state, the configuration of the guest hardware in parallel, which seems a bit unfortunate. So, to recap, we have a bunch of problems problems or things that seem not as nice as they'd like to be in terms of how we describe the guest hardware at various parts of the stack. So what do we do about it? So essentially in qemu, in order to start fixing this. We really need a clear break between what parts of the code create the device model and the parts of the code that use the device model. And that's mostly true already. The actual device models just use the device model. So essentially what I'm calling the emulator runtime here, which is all the device models, the CPU models, TCG, KVM, whatever. They look at the device model, but they don't alter the device model. And then you have the virtual machine construction, which sets up the device model in the first place, and that's essentially the command line processing. QMP and HMP can both alter that device model when you hotplug devices. And you've got the default device processing and various legacy options in VL.C. The tricky bit is machine type here again, as I was talking about before, because machine type both constructs the machine to have the default devices, and then it also does runtime setup, which is really part of the, and does things at reset time and so forth, which is parts of there. So what we need to do is to split machine type up into these two parts. The first of those I'm calling the machine schema, just as a random name to distinguish it from the existing machine type. And its job would be to construct the devices that are essential for the platform, set their options correctly, optionally construct devices that are usually present on the platform, even if they don't have to be, and what those are might depend on a bunch of options. It might depend on whether you've got graphics, whether you've got other devices, so on and so forth. And it should set up the root bus and its class and parameters. And the significance of that is that I think the sensible place to handle the runtime logic that's specific to a particular platform or machine is in a subclass of sysbus. This isn't the only way we could do it, but this is the approach I'm suggesting. So I'm suggesting we make sysbus subclassable. It can check device dependencies, the code in there. So the common example would be most devices in the system won't operate without a system interrupt controller. So we might want to verify that if there's any interrupt using devices, then you have a system interrupt controller to process those. But it should never alter them. It should just say, no, you can't do that, missing device, because any alteration of the device configuration is the job of the machine construction there. And this would also do the other jobs that machine type does currently. So loading your firmware, setting it up, setting up any CPU and memory initial state, any other system-wide reset that's necessary. So that's part one, I think, of cleaning up this handling of device configuration. Part two is to make that device configuration visible outside QEMU. So there's two subparts to that. So the first part is allowing management layers or what have you to extract the current state of the hardware configuration from QEMU. And actually you can do that now by going through all the devices using QMP and getting all their properties and getting everything there is to know about them and pulling them out. But it's a fairly laborious process because you've got to walk through the tree and extract everything out. What I would like to see is something where you can just say, give me the hardware configuration, and QEMU will spit out this blob that tells you everything you need to know about the hardware in the system. Obviously, including any devices, the current state. So anything you started with initially and anything you've hotplugged since then. And then the second part of that is to see a way that you can insert that hardware description back into QEMU. So you can start QEMU with some kind of special option, you feed it this blob of hardware configuration, and it starts up running on that, completely bypassing the normal virtual machine construction. So it bypasses the machine schema, it bypasses the usual command line construction of things, and goes straight into runtime with this pre-configured hardware setup. So the next step from that is, what on earth just happened? Oop, that's better. Is to have libvirt make use of this. Now, I don't know libvirt nearly as well as I know QEMU, so again, these are all a proposed set of actions, which I am happy to be corrected on if people have a better approach. So at the moment, as I was saying, libvirt's only view of the hardware is the domain XML. And I think trying to maintain a completely hypervisor-agnostic description of the hardware is not really possible, because what is the hardware, what virtual hardware you can construct is inherently going to depend on your hypervisor backend. So I think libvirt needs to gain a notion of a backend hypervisor-specific hardware configuration. And that could be a different format for different hypervisors, but obviously I'm interested in the common case, which is qemu and kvm, and so I'm talking about a qemu model here. What I'd like to see is a model where when you create a new VM with libvirt, it'll take domain XML, it will convert it into qemu command line parameters or whatever, in much the same way it does now. It'll start up qemu, but then it will extract from qemu that precise hardware description and store it and associate it with that VM. And every subsequent time you start the VM, it'll just use that CAN description. When you migrate, it'll use that CAN description again, so it'll always get the same hardware. And each time you restart the VM, it'll use the same hardware that it extracted from qemu, bypassing the machine construction. Now, obviously, you could have the option of reconstructing that from the domain XML. Suppose the default's changed in libvirt about what devices and you wanted to update your machines, but that would certainly require a guest restart, and it might even require guest reconfiguration depending on how finicky your guest is about exactly what hardware it's seeing. Most Linux setups these days will adapt to new hardware pretty well, but that's not always the case. So they're the parts I've thought about in detail. What influence does this have on the rest of the stack? And I think the answer is not a whole lot. Up into the management layers, you don't need to do anything. It can use libvirt just as it does now. It creates the main XML, and libvirt does what I've just described, and everything keeps going. Optionally, management layers could use something like this if they wanted more precise control of the hardware, or even if they wanted to show to the users a more detailed view of exactly what hardware is there. They could use a model like this, but they wouldn't have to. Guest operating systems, really nothing to be done there. They'd get their hardware description from ACPI or device tree just as they do now. qemu already has the code to create that for the internal model. There's not really anything new there. So what would a format to describe hardware like this need to look like? And so the first two things here, tree structure and extensible, I don't think those are very controversial. It's kind of the only natural way to describe a bus bridge hierarchy, and obviously you need to handle future hardware. Now, I think it should keep guest visible information separate from backend. So this is like, for a disk, guest visible information would be the model of the disk, the published SCSI ID if it's a SCSI disk, its size, obviously, its interface, where it appears on the bus. Those are all bits of guest visible information. What's not guest visible information is whether that's backed by Gluster, an image, a real disk on the host, what the path to that image is, host-side optimization options about how it's accessed. For a network, the model of the NIC, its MAC address, its settings, those are guest visible options, but whether it's connected to Open vSwitch or to a bridge or so on and so forth, those are what I'm thinking of as back-end details. I think the guest visible and the back-end information needs to be kept separate because there's quite a lot of tools that want to deal with one or the other, and it's a lot easier for them if they can do that without having to parse or handle the other. qemu already has pretty much all the guest visible and back-end information separate. libvirt does not in the domain XML, and that complicates things a bit. Yes, but you have to know everything about every sub-element in order to know which is which. You can't just say from the structure of it what is the guest visible and what is the back-end info in general. And it'd be really nice if it was a format that already existed, because there's less to implement, and usually if you try to make a new format to consolidate existing ones, of course you just end up with more formats. So what... I think I've got a duplicated slide here. Oops. Yes, I do. What are the options? Well, from the precise end before, I was saying there's kind of 4 down that end. There's libvirt domain XML in some cases. There's qdev itself. There's ACPI, which the guest uses, and there are device trees. I'm not going to talk about ACPI at all because I don't know anything about it. I suspect it's uncontroversial that that's a bad idea. So, libvirt domain XML. I think this is a bad idea. But just to talk about it. XML has a natural hierarchy, of course, but the hierarchy in the libvirt domain XML does not match the bus hierarchy. Instead, you'd have to construct the bus hierarchy by setting the bus addresses on your various devices, which is a bit awkward. As I was saying before, the guest and the back-end info is mixed, and yes, if you know all the elements of the domain XML, then you can identify which elements are guest visible and which are back-end, but you have to know that those are a different set of things you need to know about a NIC entry or a storage entry or so forth. The libvirt XML, even at its precise end, even the final form before it starts the VM, doesn't include system devices. So here I'm thinking of things like RTCs, system clocks, things like the root PCI bridge on most platforms, certainly x86, and those other things that you tend not to think about because the kernel just uses them and they're there. That can be an issue because you can get different variants of the machine which have new models, changed models of those, and it does matter for migration and so forth. And another sort of looser thing here is that if you get a bit of libvirt domain XML, you don't necessarily know whether this is what went into libvirt and is a fairly loose description, or if it's what came out of libvirt and had been made as precise as libvirt makes it. Plus, of course, some people don't like parsing XML. So, in short, I don't think libvirt XML is a good idea. That leaves basically 2 formats, which I'm going to talk about. qdev itself in some linearized form and the flattened device tree. Now, I don't actually have a recommendation here. When I was first writing this, I thought I'd be recommending device tree, but I am biased, of course, because I wrote tools to do with flattened device tree. And then I looked at what would be involved and half convinced myself that it would actually be a lot of work and not a very good idea. And then I heard just the other day that the Xilinx people are actually doing this already, and that makes it sound a bit more plausible again. So 2 possible options here. I don't know which is the best one. Flattened device tree, so it's used by all PowerPC Linux kernels, some ARM, and some other architectures as well. It's very easy to parse from the machine. There are existing tools. It doesn't contain any back-end information at all, so it would have to be augmented with extra information at the back end. And in the easy cases, it lines up nicely to qemu and would be quite easy to convert, but there can be a bunch of harder cases. In particular, there are some awkward places where the device tree is a bit redundant, and redundance obviously is something you don't want in a format you're using to configure qemu, because it means that you have to set things up in 2 places, and that's awkward. On the other hand, I guess the simplest approach from QEMU's point of view is just to linearize the existing QEMU info. Linearizing it isn't terribly hard. QEMU already uses JSON linearization of various structures for QMP and other things. So you can make something based on that to linearize the existing hardware description. It already keeps the back end and guest visible information separate. In QM's case, basically by having the tree of guest visible objects separate from the other objects that are used by the back end but are not directly guest visible. So QEMU always has like the drive object, which is the back end, separate from the actual SCSI disk object, which is the guest visible device. It does obviously tie this quite directly to the way QEMU does things, and it might make future changes more difficult by, to an extent, the QEM model is already an exposed interface because a lot of it can be examined with QMP, but this would make it even more exposed and therefore harder to change in future. I don't think any of these are insurmountable problems with either of these formats actually, but you know, they are difficulties. So almost done. So the question is, how do we get from where we are now to somewhere like this? Obviously, the first thing is consensus amongst developers of QEMU and libvirt that this is a good idea, or another idea that is something like it. The next step is splitting the machine type, as described. That can be done. That doesn't depend on exactly how you format that information, so that's something that could be proceeded with relatively directly. The biggest problem is just finding it does affect a lot of places in the tree, obviously, and given the amount of time we've taken just to convert existing machine types to the QOM model, you know, sort of shows how big an undertaking is to make tree-wide changes like that. So it's a question of having enough people with enough time. Then it'd be a matter of choosing a format, implementing the import and export of it, and work outwards to other parts of the stack from there. This is something I certainly hope that I will be able to work on, but it's not something I could do alone, and it's not kind of my primary work, so I don't know how much time I'll have for it. But it's something I hope will happen, and I hope I can help make happen. So there we go. We do have a few minutes left. That's where the slides are if you want, and do we have questions? Oh, sorry, I will just say before that, Eduardo and I are kind of having a joint BOF on roughly this topic, well, almost immediately, in fact, in the BOF slot. Yeah.
So I was wondering if we really need libvirt in that whole mechanism, because, I mean, the only thing that we want to do is to migrate a guest completely, right? So can't we like just put that information into the migration stream, start QEMU with a special mode, and then like do that like without any libvirt changes necessary? Just like that would be my take.
You could absolutely. You could absolutely, and putting that information in the migration stream, I think, is a good idea. That wouldn't make no libvirt changes necessary in a sense, because at the very least libvirt would need to stop trying to construct the machine at the far end if existing tools are using libvirt to migrate, and lots of them are. Libvirt is very well established in a bunch of places, and I think we need to work with libvirt whether or not you have to work with libvirt.
Yeah, well, but the changes to make that possible would not have that much impact compared to like getting whole machine descriptions into libvirt, right?
I'm not sure that's true. I don't.
I mean, that's information libvirt will just like take it and hand it to another QEMU. Nothing to do for libvirt. So I'm not sure if we need it at that point. Maybe not.
Maybe not. Alex.
So for starters, I actually like the idea that there are multiple problems you're trying to solve. Right?
Sorry,
There are a multitude of problems you're trying to solve.
Yes, there are.
There's the general problem that during live migration you don't know which. So while you can save the original command line, you don't know the devices your Hotplug added and removed in between.
Exactly.
So you need to have, basically to solve the Hotplug and live migration issue, you know that we have a thing in QEMU where you can serialize all of the command line switches and read from them. There's stuff that Gerd did, I don't know, 5-6 years ago, which basically, I forgot what it was called, save something, right? Read config and write config, right?
Okay,
So you
I
can,
did not know
so
about that.
those do exist, which serialize the config space. If you could extend those to just take Hotplug stuff into account, maybe you could just reuse those. It's an existing format. It's ini style. It does have everything you need to basically create command line parameters. It basically solves the Hotplug on migration problem. It does not yet solve you the I want to bundle a machine description and the machine files together problem, which is another one that actually is pretty dear to me, rather. Most of the other hypervisors have a mechanism to give you an image and the description on how to start this image. And in the qemu world, you give people an image and then tell them to do something with it. Say a shell script, for example, which is usually a pretty bad idea. So we are definitely lacking some mechanism to give people something in their hands that they can just run a VM without worrying about anything at all. It will just contain information like, I need 1 gig of RAM, I need these specific devices.
That is exactly what I'm getting at here. One actually potential bonus of this is it does have the potential to make it easier to be disciplined about machine types. At the moment, we have to be very, very careful that for any kind of version of QEMU that people have seen and used, the versioned machine types have to stay the same forever. Now, this would potentially make it easier to maintain that if the version forever versions are given this detailed description that you're putting back in, whereas sorry, I'm getting myself very confused. But I think doing this, because users have the option when they need a very precise hardware setup of doing it directly, it gives you more flexibility to be less precise and less exactly the same over all time about your easy configuration method, your friendly and loose configuration method.
The friendly configuration is really just the backends. That's all you configure. You just say my disk image called A is there, and that's
that is
all
a
you
good point.
configure.
Yeah,
because the VM is set in stone. The way the VM looks like is set in the config file.
Right. Well, yes, and what you would need to do on migration, you would need to provide back-end information on the destination, and you would then need to validate that it contains all the backends that your machine description needs.
Yes, but you do need to do the same if you do read config. And that's a problem that basically this is roughly where GERT stopped back in the day.
This is actually getting a long discussion. How about we move
We can
this
definitely
into the
take this to the BOF, but I would really encourage you. I do not believe we need to change any QEMU internals, introduce new random buses that record anything at all there. I do believe this should be doable with the infrastructure we have today. I don't think you need any intrusive changes. You could just use reconfig, write config, extend them to take somehow the Hotplug stuff into account, and then have some sanity checking mechanism that allows you to verify whether you plug all the backends in on the command line when you boot it.
Okay. Well.
Come up. Microphone, otherwise it's not going to get recorded.
Right now, the parsing of the command line arguments and the creation of the machine is basically intermediate. It's not easy to get them together. This is other of the problems that we have now. We are doing the two things at the same time. We are not passing all the command line, all the configuration files, whatever. We create one infrastructure that is the thing that we need to save configuration, and then we create from there the machine. No, we are doing that intermediate. That is the problem that we have.
Yeah. So this all sounds like interesting discussion, but how about we move that to the BOF and actually have people who have questions ask them.
Actually, I have a very short question. Can you show previous slide, please?
Which slide, sorry?
Previous one.
This one? Hang on.
Yes, exactly.
No,
this one.
This one.
You see about point 1. You should not achieve consensus not between qemu and libvirt, but about people using libvirt because you would like to change a wide description which is used by OpenStack and all other people.
Well, they don't, like I say, it doesn't have to be that way. They could use this if they wanted to, but that certainly doesn't have to happen in the short term. That's kind of further in the future if they want to change.
Yes, and if we are speaking about the future, we should take into account opinion people using this interface.
That's true, yes. Yes.
So first a comment, I believe in most places where you've actually talked about QDev and QDev tree, I believe you should actually be looking at the QEMU tree instead. Because if you look at the QDev tree, then you have a bus-only view of the system devices and you're going to miss a bunch of modern devices.
Yes, possibly. Sorry, I haven't been terribly precise in my use of QDev versus QOM. I think initially I was talking about QDev to represent the guest visible devices as opposed to the QOM objects which are not guest visible. But that may not be. I don't think I've used those terms terribly well. So, yes, apologies for that.
So, and we've been trying to actually get rid of that strict bus structure that QDev imposed on us. So I really second the notion that subclassing sysbus is not really the way to go when other people are actually trying to actually preserve the cool infrastructure that sysbus devices are giving us, but not really seeing any need for this bus anymore.
Okay, well, let's discuss this in the BOF.
So, and then the main question is, I didn't really understand why you feel that you need to export or import any file format for this representation at all. If you actually want to know what the guest is doing, then libvirt can just use the QMP interface to get that information from QEMU directly. And we do have lots of imposed ABI stability rules to actually make this work. There were even properties being added specifically for libvirt, which then somehow libvirt ended up not using.
Yeah, it's not essential, but I think the easier it is to get this data in and out, the more likely it is to be used correctly or used productively. Like libvirt could do this, or any other tool could do this, but if it's easy to get in and out, I think that's going to improve the state of affairs.
What do you need to get it in for? I mean, out, we already have scripts that do that in Python.
Oh, to get in, so that you can construct them. So if you've previously extracted the precise hardware configuration of a machine, you can construct a new identical machine, which you want to do in migration for certain, and you may also want to do in other cases.
Right, but you can just set the properties directly since you already have the objects created from the machine construction.
Well, no, but I'm talking about bypassing all that logic that sets up and applies defaults and all that, because...
you bypass it, and then you just set the properties. Already have the properties to set properties. We don't have the properties.
Right, again, but it's a whole complicated process. You've got to create all the devices in the right order, you've got to set the properties on them, hope they don't have any odd interactions. If you've got just a blob that you can feed it as one unit, that's a lot easier to work with as an external tool, or a direct user if you're testing it.
Right, but that was pretty much what the config files, what can also be written by the write config and so on, was actually Anthony's motivation for writing this whole QM thing, so that you can have a config file that describes the machine and then creates the devices the way they were described.
Yes, well, it absolutely sounds like I need to look at that in more detail.
So I believe the problem with the read config and write config is that it ignores completely what's done by the machine types today. So we have lots of stuff that's inside machine type code. We want to bypass that, and read config and write config, we don't have that information.
You can use the existing format file and the existing infrastructure to create additional devices that the machine does not create as such. So there is the infrastructure for getting all the information in, and there is information for getting. There's ways for getting the information out already without inventing any. You mentioned some flattened or whatever linearized QEMU format. So
the way I'm looking at that is, it sounds like this read. There is already a linearized QEMU format which I was not aware of. No. So it's nice to be made aware of that. So that is absolutely something. Lane.
Okay, so, well, you may not be aware of some of the history of libvirt, but I think if...
I may not indeed.
Yeah, if you were if you were wanting to propose that libvirt use some other method of describing machines other than XML, you should have done that 10 years ago, basically.
Well, bear in mind, I'm not suggesting replacing the XML. I'm suggesting that the XML remain the generic way of describing a machine, to the extent that it is possible to generically describe a machine, and that this other thing, which might be a read config or whatever, be essentially a cached backend. This description would be owned by the backend driver.
But all of that information is in the XML, or if there's something that's missing that's necessary, then it can be put in. But
it's for some that's it's not on the XML, but it is inside qemu. But we don't want to rerun the virtual machine construction step. We want to bypass that. Just get what we already have.
But what you're saying then is that you want libvirt to store something else in its configuration, which for libvirt means storing it in the XML in some way.
Well, the problem in this case is we want to avoid tracking things in parallel between qemu and libvirt. And if they're to be stored in libvirt XML really at any stage, that means extracting the information from qemu and converting it into XML, which you can do if you really want, but it sounds like a unpleasant task.
So it's basically a binary dump of the kernel configuration, right? So you could write that into the XML file if you really, really want to.
I think.
Yes.
But the information, the necessary information, is already in the XML.
No, it's not.
If it wasn't, it wouldn't be possible to migrate.
It is, but it's fragile.
Yeah, I would agree with that, and I think that what you're
very,
saying
very
about
fragile.
being able to query exactly what is in a machine type is a very useful thing that we would welcome. But and maybe I'm misunderstanding a bit of what you're saying about that, but libvirt is still going to have all the information about the PCI addresses of every device and all of that in it. That can't go away.
Why not?
Because
Say it differently. The information that's going to be there, either you want to have it on the XML or you don't want to. It depends on the kind of information. If you don't
no, if you don't do it,
not have to. Sorry.
Look, we're about 10 minutes over at this point. How about we adjourn to the other room and begin the BOF, because it sounds like we have already.
If that information isn't in the XML, then the management applications don't have access to it. It has to be there. That's you can't not have that. What you're saying is the tight information. You can't not have that in the XML.
I see what you're getting at.